Hello. Hi, everyone. I'm Sebastien Couture. I'm the founder of Interop Ventures, and I also host a couple of podcasts. Some of you may be familiar with Epicenter. I also host a podcast called The Interop, and organizer of Nebular Summit, which is happening Monday and Tuesday of next week here in Paris. It's an Interchain Builders Conference, and I hope to see some of you there. So for this presentation about IBC, I thought, who needs boring bullet points? Want to have a presentation of ChatGPT generated haikus. So that's what you'll see up on the screen. And so in this presentation, I want to talk about the Interchain Inter-Blockchain Communication Protocol, IBC, and progress that's being made to bring IBC to Ethereum. Who here knows what IBC is? Who's working with IBC or building on IBC? Okay, great. I'm always afraid that there's someone in the room that's much smarter and can tear apart my presentation. So first, I heard Hasu say this on a podcast recently, and it kind of blew my mind because, as someone who has been really passionate about Ethereum, but also Cosmos for the last couple of years, I thought how is this true? IBC exists obviously in the context of Cosmos. It works really well, but I don't see a lot of progress being made, or there's no tangible use case right now for using interoperability solutions, or at least open standards for interoperability between Ethereum and Cosmos. And so, this quote kind of stuck in my head, and I thought it's really cool. I'd love to see those two ecosystems come closer together, but how do we get there? And the answer is open standards. And I think that one open specification that has potential to become a standard here is the Inter-Blockchain Communication Protocol that was built by the Tendermint team a couple of years ago and is now in production and is servicing thousands of transactions per day and millions in volume. So for those who don't know what IBC is, it's a universal interoperability protocol. It's a specification that allows different blockchains to communicate with each other. What it does is it guarantees reliable, ordered, authenticated communications between different areas of state, different domains, essentially, if you will. So it allows authenticated message passing between these heterogeneous domains of state, and it's designed to be secure, it's designed to be modular, efficient, and it has, obviously, something that's really important for interoperability is data packet ordering. And one of the core tenets of IBC is that it pushes trust to the counterparty chains. So with IBC, I kind of joke around about this once in a while. It's if you want to use IBC, you don't have to trust the bridge. So if you're going from the good side of town to the bad side of town, you can always come back as long as that bridge is still there, and you will always know that the bridge is still there. What happens on the other side of town, though, is your problem. And this is really important, I think, to have trust minimized solutions that enable that sort of risk mitigation. So if you're comfortable interacting with another domain of state, another chain, you can do that, but the bridge will always stand under your feet. So this protocol has been very much inspired by the OSI model, and it works similarly in this layered approach. And there's three layers. We're going to focus mostly on the top two for a second, and we'll come back to state. But essentially, while most users will interact with IBC at the transport layer and at the application layer, the state layer is also very important. So let's talk about the state layer for a second. This is light client verification. So chain A verifies the state of chain B through a light client, and the commitments are verified from one chain to another. The source blockchain creates a proof of a packet commitment, and then it demonstrates to the other chain using its light client that the proof can be trusted. And so light clients are a very important part of IBC. It ensures the security and the efficiency of the protocol, and this is how Cosmos chains talk to each other on a regular basis. Then we have the transport layer. This sort of mirrors TCP/IP in the OSI model, and this is the layer, this is the backbone of IBC that enables secure cross-chain communication. It handles the authentication, the transmission, and ordering of packets. It makes sure that that a chain can verify that a packet is coming from the chain that says that it is, that there's no man-in-the-middle attack or some sort of like, cross-chain Sybil attack where a chain would be spoofing the identity of another, and it guarantees that reliable connection between the chains. And finally, the application layer, and this is where the fun stuff happens, and this operates on top of the transport layer. It defines the logic for receiving data packets, and this handles various applications. Think of this as the SMTP, the HTTP, and all the kind of like higher layer protocols that we use every day. And this provides the versatility and broad utility of IBC. And so things that operate at the application layer are ICS 20, so the equivalent of ERC 20 tokens, to move fungible tokens, to move non-fungible tokens. We can do things like cross-chain queries, cross-chain atomic swaps, even interchain security. So all these use cases where one chain needs to send messages to another, there's a protocol, there's a corresponding application that defines the standard for how that data is being transferred. Now, the challenge when it comes to interoperating IBC with Ethereum is really the state layer. And this has been the challenge and continues to be the challenge, and will be something that we'll address here in this presentation. So the EVM does not support the efficient generation of verification of Merkle proofs, and because Ethereum uses Patricia cheese and IBC, because it came out of the Cosmos SDK, uses Merkle proofs, that verification on the Ethereum side can be very expensive. So basically, building a Merkle proof verifier on Ethereum would be very costly in terms of computation. And then there's the finality aspect as well. Because IBC was built for Tendermint, it has single slot finality. The two slot finality in Ethereum poses a problem for Byzantine fault tolerance. So what are the solutions? Well, there's a couple of solutions that are being built currently by a number of teams that I can talk about. One is Optimistic IBC. It's a variant of IBC that allows for the acceptance of state roots optimistically, so a lot like an optimistic rollup. The security here relies on tokens that are staked on an intermediary chain, and so there are a number of teams that are building this sort of like intermediary chain that sits between two domains of state that would take on the risk of a fraud proof being verified. And it allows for participants to submit fraud proofs so that we can optimistically verify the transfer of tokens or messages across different domains of state. Then there's ZK IBC, which is essentially having a ZK verifier that can generate a proof that can be verified like a snark, that can be verified by an Ethereum smart contract. So there are teams working on Tendermint-like clients that generate this proof that's compatible with Ethereum, that allows the batches ED 25519 signatures that can be verified by Ethereum. And these are inspired by the types of ZK rollups that we use currently in the Ethereum space. And so teams that are working on this are like the ZK IBC team, Electron, Amherst Labs, and Polymer, who've built this ZK Mint like client. And then the final part of this, and this is one of the big issues with IBC that's being resolved, is that there's no routing. So when you're moving tokens from one chain to another with IBC, you can't do like this kind of multi-hop where you go from chain A to chain C through chain B in a single transaction. You would have to do that in 2 transactions. And so multi-hop IBC is the future of like cross-chain routing, where we can find efficient paths even though we don't have direct paths between one chain and another, and where it becomes useful in the context of interoperability with Ethereum is that if we want to have interoperability with Ethereum in a multi-chain application-specific blockchain or application-specific rollup world, that means that like every one of those chains has to have a connection to Ethereum, either through like an optimistic IBC construction or a ZK IBC construction. So using this multi-hop IBC, we can have these intermediary chains that would facilitate that transaction and do this multi-hop. So you could go, for instance, from like Juno to a chain like Polymer, which is working on this problem, and then to Ethereum. And so it leverages it leverages leverages zero-knowledge proof to create this efficient connection between different domains of state without having to have like a one-to-one on every single chain going to Ethereum. So to finalize here the talk, I think when it comes to interoperability in blockchains, we need to be very conscious of the benefits of building on open standards. And I mean, we're all here because we love the open web and we're passionate about the future of Web 3. And Web 2 was able to flourish because of open standards. When it comes to interoperability, there's a real risk that interoperability gets captured by proprietary protocols. So one analogy that I would kind of pose here is, imagine as every time you had to send an email, you had to pay a fee to like Email Inc. because they operated the protocol that allowed us to send messages. And there's a risk that happens in blockchains as well with protocols that are not operating on open standards, where there's no default to an open standard, and that really capture the market for interoperability between chains. So, where we have sort of won with open standards are HTTP, obviously, TCP/IP, SMTP, these sorts of things. These open standards continue to proliferate and have built trillions of dollars in market cap. Where we've seen more failures with open standards, I think we would all agree, are things like messaging apps, social media networks where they're permissioned. There's risk of censorship and certainly corporate and political control. So I would ask all of you to sort of keep that in mind when considering what protocols to use for interoperability. And I'd end this with this quote from Punk 6529, which is when everybody was having a debate about Donald Trump and whether or not he should have access to his Twitter account, nobody was having any debates about whether or not he should have access to email, because there was simply no way that we could enforce that. And I think that's really important also in the context of blockchains and the types of technologies that we use to provide better interoperability between systems. So if you're interested in this topic, and broadly if you're interested in the Cosmos ecosystem and the Interchain, I would invite all of you to check out Nebular Summit, which is the conference that we're hosting next Monday and Tuesday here in Paris. It's happening at the Albert School, and we're actually kind of kickstarting the event on Sunday with Nebular Hack Day. There's a full day of technical workshops and technical talks that are designed really to help you boost your skills and sort of like learn how to build on the Interchain, learn how to deploy smart contracts, learn how to build with IBC. All the details are at nebular.builders, and you can follow us on Twitter using this hashtag. QR code, sorry. Yeah. Thank you. I'll leave it up for one more second.